Okay, just not seem to be working. I can't see much with these lights, but well, if you have any questions, please raise your hand or feel free to interrupt while I speak. In case you don't know me, my name is JAIME Peñalba. I work as a kernel researcher at COSA Inc. I'm not here to talk about kernel. I don't want to bore you at this time. And I also collaborate with Radar2 and Riddle's Pipe on Node.js. And then we worked on the rest of the implementations in different languages. I've also been the mentor of the Radar integration with the kernel on the R2K model for the students who were doing that. I'm a WhiskeyCon superstar, something a colleague gave me some time ago. You may find it on YouTube. And I'm a speaker at RootedCon. And I've been here for the last... I haven't been here since 5 years, I think. So since I'm here, I want to tell you about something quite interesting that I've seen lately. And I also want to apologize if the slides are not good. I shouldn't follow Clippy's advice, who's asking me to use word arts. But lately I see many talks, many presentations called how to protect your server using Docker containers, how to use hosting containers, to analyze vulnerabilities, how to do malware analysis using Docker, or whatever security, insert Docker here. And any similarity with reality is pure coincidence. And the titles are just randomly chosen. I'm not trying to attack anyone. So this is my talk when I hear those presentations that I've just mentioned. Why? If in a virtualization environment we want to take control of the machine, or persistence, as we call it in the system, after we get into it, either remotely or due to a script PHP mistake or a Apache mistake, a browser, whatever, with a normal virtualization system, we usually need to escalate privileges in the virtualized system. Then once we have root privileges, we attack the drivers. That's where the errors and bugs usually are. And when we attack the drivers, we leave the virtual machine, we go to the host machine with the user permissions. And then we need another privilege scaling exploit in that host machine to get that path. Usually, these are 3 bugs. 3 bugs plus the one that you may need to get access to initiate the machine.
Okay.
So what is it that we need with Docker? We need just one to escalate privileges, and that's it. So Docker is the same kernel based on the same things that are implemented by kernel. So when we do a privilege escalation, you're attacking the same. And not even Bitcoin likes this. So please do not use Docker as a secure container or as a security mechanism. Use it for what it is, to keep an orderly system or to deploy something. So I do not mean to criticize or defy or be disrespectful towards them. They've always been very professional and they've dealt with the reports very reasonably well, and I fully agree with how they do the bounties. And if you want people, expert people to work on your bounty rather than that of better known companies or that offer greater rewards, then you need to offer an attractive reward. Of course, nothing in this world is perfect, and this bounty was no exception. So what's this all about? We are in the Radare channel, and somebody came and put a link, and saying that they came from Shopify and they had opened bug bounty. So we discussed it with some friends in the channel and we decided that it looked good. And we also, in fact, one of our friends works there in Shopify in Canada in the security department. So we asked him, is this true? Are they really going to pay this? And he said, yes, this is the way it is. We've just opened this and take a look. And we decided it could be interesting. And a month later, this came up in Twitter. They had apparently paid quite a lot of money in one day, and about a fourth of this was split between a colleague of mine and me. And this is a graphic description of big bug bounty in open source. You always lose. There's no way not to lose. So what's the goal? The goal in this case was a Ruby interpreter, and this is a bit strange because it's Ruby which embeds or integrates another small Ruby. So the interpreter they used was mRuby, which was a very light implementation with very little code, which is nothing to do with the original one, which is quite big. And what these people did was to integrate this mini Ruby machine using a plugin or a gem. And what they do is to offer a sandbox environment so that the scripts can be executed safely or in a secure way. And they do that because they have this very large shop structure. So the customers, the high-level customers, depending on what you pay, some customers allow them to execute in their shop their own Ruby scripts. I think their whole infrastructure runs on Ruby on Rails. So if you allow other scripts to be executed, they may get out and interfere with your infrastructure. That's why they try to do that. So this is a very poor drawing because I've told you OpenOffice is not my thing, but this is the Ruby interpreter. This would be the whole process, one process. And then it installs the Ruby gem, which is an SO point, like a library, and this library has inside the Ruby interpreter. And this is a single process, and it has the same memory. What this plugin does is to implement some sandbox options by limiting the memory usage, execution time, and the number of instructions executed. It's compiled without most dangerous functions. You can do no input-output to the file or network, and it doesn't allow to require. So it's very limited. And these are, for instance, out of the core gems. And these are very basic things that are allowed. So as you can see, these are very basic functions that are allowed. And this is an example of how we would execute the sandbox. It's a normal Ruby script because it runs on Ruby, and we include the plugin of these people, which is this mRuby engine. And here it defines the 3 megabytes, and these are the instructions and the time. And here it defines the engine with these constants, and finally it introduces here the file we want to execute so that it's executed within the sandbox. So if we look at what these people were offering, we don't want to work too much because we have work already. And we're not interested in the logical failures. We didn't want to. We discarded these 3. First of all, this 1,000 euros payment was not interesting, and we have these last 2 who were interesting. We discarded also this one because of reasons that I'll tell you later on, and we stayed with the ones that we were interested in, which are denial of services. So what did we do? Well, we fast, which is the simplest, and as this joke says, it's sad, but it works. Somebody says, I wrote a vulnerability scanner that abstracts all the predicates in a binary, transfers the call graph and generates the formulas, etc. But then I've found one vulnerability in 3 days, but this guy here with the fuzzer found 3 vulnerabilities in 1 day. And this works. So what's the normal process? We studied the case and we set up everything. We let the fuzzer work. So you work on something else, or you play on Battlefield, or you go out for a drink, and finally you just collect the benefits. And that's all. Do you guys have questions? No, I'm joking. There are a few more slides. So this is what you usually do when you do fuzzing. You collect samples. You do the corpus distillation to discard the ones that are executing the same code or the same code parts, and so that you don't mutate samples that do the same. You do the fuzz, you do the triage, and then you debug. So the hard stuff is debugging. Fuzzing can be done by anybody, but what's difficult is to know how the program works, so you can exploit it, etc. So fuzzing could be done by anybody. In fact, I don't do bug bounties. This could have been done by anybody. And the complicated part is debugging, because finding vulnerabilities with fuzzing is simple. And finally, if you're lucky, you get profit. And in this case, we have only done 2 things. We've added 2 things, which is to generate a dictionary and to write a wrapper. And why a dictionary? Normally, fuzzers are very efficient when they have to mutate binary data, a PNG or a video or headers, or they're not so good when they have to fuzz languages or deals that are, or things that are words, and they have to have a meaning. So our best option for that is to create a dictionary with keywords, operators, etc. One of the ways of doing it, which is faster and usually works, is to extract the data section and extract all the strings. This is quick, but it adds a lot of noise to the dictionary. It's mixed up with the error messages of the application and other things that are completely unrelated to the keywords of the language. So we're going to be generating mutation with useless words. And we can do that with a single radare command with -z, and that extracts strings and it tells you the section. And if you add -j, it gives you even more information and get the strings only of the section you want. Another way in which you can generate a dictionary, which is the one I use in this case, we have the application code. And this is an interpreter of a language, and in some way it has to define which are the language classes, which are the operators, which are the basic functions, etc. Then you have to do that in a way, and we identified that it used these 3 functions. It uses a few more to define all of these paraphernalia, and you only need to do a grep with all of these. Anything that starts with Ruby define, and it gets here the typical toString, etc. So with a bit of script base, you could patch that and generate a dictionary. This is an example of dictionary for the language. This is, so you had string, struct, and basic types. Something very important as well when you're fuzzing is to look for, when you're looking for bugs. That has been good for both for developers and for bug hunters are sanitizers, which are in the compilers. These are instrumentations of the code in compilation time rather than execution time, and it helps us to detect many things. Use after freeze, heap overflows, etc. In this case, to use sanitizers, because it was Ruby, You do the usual stuff, which is to define LD flags and CFC flags to add the sanitizers we wanted. And then we have to edit a file, which you can also enable in the integrated interpreter. Then we had to do a wrapper because the fuzzer, as I say, needs to instrument the code, and it also does a couple of hacks, a false server to make the fuzzer quicker, and the process to fork rather than execute it 20 times. You do a fork and things that I don't need to tell you right now, but we need to instrument it. We had several options to instrument the whole process, not only the sandbox. And that would take a lot of time. And then when it came to the fuzzing, it would be heavier to instrument the code that we do not need, and it would have less executions per second. And another option is to instrument only the mRuby interpreter without the sandbox that was set up by these people, but this generated problems. And then you reported bugs in the interpreter, and they said if it was no good if it was not within the sandbox. So things that weren't really true because the bugs were there. So we had to discard that one, and the final option we chose was to set up a small wrapper around this Ruby gem, which had a small program that loaded the gem, the Ruby gem, as though I was the Ruby interpreter. And this was quite simple to do with some 85 lines of code, and you only need to initialize a memory pool, read the script, parse the code, and execute the code. We had to do a couple more hacks, small hacks, but because it's a Ruby plugin, you had to control exceptions, etc. But it wasn't very complex. This is a part of the code. It's just 85 lines and 30 more lines at the end. If any of you are interested, this is the code generated by the fuzzer. You can see to the left it generates code that looks meaningless. It introduces bytes that are not text, but the interpreters discard the text-less bytes, and then it generates strings with keywords. And in other cases, it generates code like the one to the right, which seems to have more meaning. So once we have the fuzzer working and we generate crashes, we have to do the trashing, because if you end up with 10,000, 11,000 or 1,000,000 crashes, we need to be able to analyze them quickly and see which ones are important and which ones aren't. And to do that, we find sanitizers very helpful because they help you classify bugs very quickly, and with some 78 lines of bash, we could do it. It's not the prettiest, but it works. In other cases, I don't do it this way. I have other tools, and I introduce that in a database, etc. That's how I do it in kernel. But this is simpler this way here. And if somebody likes AWK, I'm sorry, because I'm terrible at this. We take the type, the output provided by the sanitizers, and the type they generate, they think it's the bug, the address where the crash has happened, and the function if there is a name of the function. And what's the final result after doing some triage? In 2 weeks, we have 12,000 crashes and some 50 unique crashes. As I've said, with the bash script, we organize it by folder, if it's a Stack Overflow or Buffer Overflow, and then the address and the number of functions. In the meantime, in Shopify, I imagine them sort of in this way. But what's the result? The result is that we only had time. I personally only had time to send 6, although I had 50 because we had to travel to China, and my other colleague also sent just a few. But with those 6, we got quite a lot of money. If I'd been able to send the 50, it would have been great. I have to emphasize that Montaro likes this a lot. And after this, there was a bit of revolution. HackerOne was very happy because it struck or broke records, but not everybody was so happy. Pedro was saying our code is so awesome, so let's show her some free money if anyone finds back here. Free money from Shopify. And this one said, this is crazy, 10 cards for this, because it was all rubbish, really. Because we didn't have time. I didn't do the exploit, but I only sent the OS as the crashes as the OS. And imagine how bad I was, how little time I had that I could only send 6. Audit, VOT, no, let's just organize a bounty and let these guys do it for us. Shopify said it's time for some game theory. 1 out of 356. I guess Shopify didn't expect that. Was using MRuby as a sandbox, etc. This one is a woman that I think is in charge of the book bounty or book round, and she says they start a bug bounty, they spend $500,000, and then they activate the sandbox. I don't know if this is a success or a failure. And this last one, I need to burn a new security budget before the end of the year. And Charlie Miller says at the end, I call this a bit of an expensive success. So after all this, they did an update to the bug bounty like a month later. And they said that they were going to lower payments to 10% of what they were giving. So if they were giving 10%, that's not 100% that they gave 10 now, so rubbish, basically because they've introduced the sandbox in another Tecom sandbox implementation in kernel. So this is the Shopify solutions, the solution. So the code of the new sandbox they have not given us, so we have not been able to audit it, but still they would have to have a third sandbox to introduce those two into that one. And it was so polemic, so controversial that even the CEO came out with an explanation saying that it wasn't a surprise, that they expected this, and because it's not a Silicon Valley company, and he was actually saying that they sometimes they've been able to make $300,000 at particular points in time, like on Black Friday. So they said that they had expected this already. That is a technical strategy, so that people will sort of pay attention, and that this was a one-on-one from the business world. And I think this is the explanation that they gave to look better. You may believe it or not, but I think I do not believe it, because 3 months later. And I left this because the payments went down, and we can't waste time with these things. But last week, I used the triage once more, only for what I had fussed about 3 months. And with the last version, there are still 26 unique crashes, and some of them are different from the ones they had before. So either when they did the patches, they've done insufficient patches, or when they've done the patches, they've enabled new code segments that I hadn't reached before. And if they say that it was just elementary business strategy what they've done, well, I'm not impressed with what they've done afterwards. I did a small bonus for DevOps of what I think should be the recommended steps. I don't work in DevOps. I work as a systems engineer and as consultant for many years as well. And I do have some ideas. So first of all, I would integrate continuous fasting within the development process. I would order an independent source code audit, and then set up a bug bounty. First, this continuous fasting, I think libfuzzer is best suited for this. And I think for this case of integration, libfuzzer is really the most comfortable because it works with STD and it's easier to introduce the results in the database. A good example of this is cluster fuzz, which is what Google used to fuzz Chrome. They have some 700 virtual machines fuzzing continuously, and then there is an OSS fuzz, which is available for open source, provided by Google. Not to all projects, but if they are important enough, yes. And this is my colleague that reports a lot to open software, and lately what he does is he sends a sample with libfuzzer so that the project development can integrate the fuzzing project in the development project. And you can see some examples here of the outputs generated by OSS fuzz or the reports they do, a specific report of a crash. So the process generally, this continuous fuzzing process, is you generate the fuzzer, the configuration, you Jenkins helps you to generate, then you compile it, you send it to the Google cluster, and cluster fuzzes it, and with the crashes it sees, it opens issues in your ticketed system, and the developers see them and they fix them. So that's if I do a new commit, this is going to be compiled by Jenkins, and it will be fast, and if there are with a new commit have introduced new failures, then you're going to be more or less confident that you have something that can find them. As to Google Chrome is a good example because they have some 700 virtual machines, 500 of them with ASM, 100 with MSAN, and another 100 with VSAM. And this is an example of the crashes they get, how many unique crashes, the previous ones, how many executions per second, etc. And they fuzz this by component. As you can see, they have the CRE, the H.264, the components separately, the one for sources, and they fuzz them one by one. They do not sort of lift the Chrome itself. These are statistics ones they published on that day or in the last 30 days. 120 fuzzers, they had found 112 bugs, and they've made 14 million executions or unique mutations. And this is a diagram of the type of vulnerabilities that they detect in the Google Chrome project, and I can tell you that it's very effective. It's one of the reasons why finding a bug in Chrome is quite difficult. It's one of the hardest, because what you find in fuzzing has been found by cluster fuzz next day, except for logic bugs. So in this case, we've killed most of the silly fudge, and this is the time to order a code audit to a consultant or to your cousin or to whoever. And because it's enough with a month or a week, depending on the project, we have to put pressure to. We do not want to hire a consultant to use the fuzzer. We want somebody who's going to spend a month reading the code and finding the logical shortcomings or failures which only people can find. And once we've done that and we've killed as many logical failures, then is the time for bug bounty, and for that we have many options, HackerOwn, Background, Yogosha, or if you don't want any of these, you can, from your own web page, program a bug bounty. And finally, I want to thank Bro, that works in Shopify, who is one of our friends, and Reveskills, who is a colleague and was also fuzzing and competing to steal the bugs. And that's all. Thanks very much to root.com, and if you have questions. Thanks very much. Congratulations for the talk. You've said at the beginning that during the first phases of fuzzing you can do a collection of scripts in Ruby. Where did you get those from? I didn't want to go into all that because it's the normal fuzzing process and corpus distillation. You get it in different ways. You may do it in Google or getting examples from the documentation. In this case, if you have unitary tests, you can get the unitary test from the project. In this case, I used unitary tests that they had, a couple of examples from Ruby tutorials because I don't do Ruby, and I wrote a couple of examples in Ruby myself. I didn't take many. I must have taken some 20 because the problem of doing corpus distillation in code is that almost any code is going to execute different paths. So I left it at 20. This was done, we did it just sort of with some spare time to see if it worked because we had other work to do. But the best solution is either unitary test, or if it's a binary format, as in PDF, you go to Google and you download as many as possible, etc. And unitary test is usually the best solution because they tend to do many tests where they've had bugs, and they exercise different parts of the code. Any other questions? Hello. The question, I understand the production part introduces sanitizers to begin with, but why did you use sanitizers when you were looking for mistakes or for bugs? Well, sanitizers is a way, if you're fuzzing, when you execute a program in your machine and it crashes, the system doesn't give you enough information. A sanitizer with dynamic memory gives you a whole map of all the memory that has been reserved in a dynamic way, which one has been released, who has made this reserved of 1 mega of memory. So you don't only know that this has crashed, but that this has crashed because this part of the code reserved this byte of memory and this other part of the code liberated it, and then this other part of the code tried to access that memory that was no longer reserved. And that's why the program crashed, because of this random data. So that's good to do those things. And in fact, in production, you don't recommend it because it adds overhead. You're using a lot of extra code. Rather than doing a mob, you have to call this function to see if the memory is reserved or not. So in production, you don't recommend it. You use it in development when you're trying to find bugs and when you're trying to debug. It's a great invention, the best thing that has come along in the last 10 years. Any more questions? Okay, thank you very much.
Recordad, por favor, votar.
Please remember to vote. You have information in Twitter, and we're going to extend the lunch break. Please be here at 4:45.